Perfect. Cool. So, good evening, everyone. Thank you for taking the time for being here. Today, as you can see from the slides, I'm going to talk about robot testing in Flutter, and hopefully by the end of this talk, you will enjoy more writing tests for your mobile app. So, before we start, just a quick introduction about myself. I'm Lorenzo Greco. I'm principal mobile engineer and tech lead manager at PrimaryBit. I have a background of a native developer, doing mobile apps for 10 plus years, and since I guess end of 2018, when I discovered Dart and Flutter, basically decided to do the switch from native to this amazing cross-platform framework, and I never looked back. So the agenda for today is going to be divided in 4 different sections. The first one, I'm going to talk about testing Flutter app in general, what are the different testing strategies that we have. Then I will dive in more into integration tests and what is the usual way of running them. And then I will introduce you to the robo pattern and to the benefits of this pattern. And then at the end I will talk about also some the widget tests and how we can apply robo pattern also to widget tests, not only integration tests. So let's start talking about a bit about testing in Flutter apps. I'm pretty sure that 90% of you already know what I'm about to say, but I'm going to spend just a couple of minutes to create a foundation for the talk, talking about the different test categories that we have in Flutter. We have 3 main categories: unit tests, where basically we test a single function, method, or class. We have widget tests, where we test kind of a widget. And then we have integration tests, usually referred to as end-to-end tests, where instead we test a big portion of the app or kind of a complete user journey. And where we basically test the app from our device through all the services in our platform. Of course, with different test categories, there are some trade-offs that we have to take into account. So in this table that is taken straight from the documentation of Flutter, you can see on the left, that unit tests are very low in terms of confidence and maintenance cost. There are a few dependencies, but they are very quick when it comes to execution speed. On the other side, integration tests are the tests that provide us with the highest confidence, but this confidence comes with a cost. Particularly this maintenance cost, we have a lot of dependencies, and when it comes to execution speed, integration tests are fairly slow. So let's see integration tests a bit more in detail. So as I said, the good thing about integration tests is high confidence in the test, because basically test the app from the user point of view. So they basically check that what we expect the user to see and do is behaving as expected. And then they can also be explained to non-technical team members. So integration tests are fairly easy to understand when we want to explain that. But then there are some warnings also with integration tests. In particular, those warnings are about the execution speed, but they are slow. To run integration tests, as you might know, we need to run them in an emulator or on a real device. And then if you decide also to integrate those integration tests into some CI/CD platform, then they could be very expensive. Also, they are hard to read and so to maintain, because also all the dependencies they have. But on this point, we see how the robo pattern can help us. There are, of course, a lot of dependencies involved, and also depending on your team structure, you might have the QA team that is responsible for writing them, and maybe some of those of the members of the QA team are not very familiar with Flutter, so they might be struggling a bit in writing that. So now let's see what is the usual way of running an integration test, right? So first we start with a sample app. This is just a very simple app with a login screen and basically we will be analyzing two different scenarios, right? So the first one, when the user enters the right credentials, is able to see like a welcome message, and the second one is that when the user enters the wrong credentials, and we show them like an error message saying that there is either the wrong username or password. This app is implemented using Fake Store API, which are some mock API that you can use to simulate this kind of scenarios, and they come with some hard-coded value that you can use in terms of username and password to simulate the success or error scenarios. So, I'm not sure how much you'll be able to read here, but basically let's now try to write a step-by-step test. So the first step, of course, when we want to test the app is to run the app, right? So the first thing we will do is to call app name, run the app, and then comp up and set to make sure that there are no dimensions running before moving to the next step. Then, what we would expect the tester to do in this case is to start to enter the username, right? And as you can see, for a simple thing like enter the username, the code can start to be already a bit verbose from a non-technical team member point of view, right? So we have to define a key, we need to assign the key to a widget, then we use a finder to find that widget in the widget tree, and then we enter some text in the text field, and then we call pump and setter again. And the same goes on for the password text field. Then, once that we have username and password, we ask the tester to tap on the login button, and finally, we verify that we see a welcome message on the screen. So this is the standard way, the usual way of running an integration test, right? And when it comes to the error scenario, the test is pretty much similar. If we put them side by side, you can see that the main differences are two, like they are the credentials that we are using to run the test, of course, because with different credentials we will get different results. And then the expectation at the end, right? Because in one case, in testing a success scenario, so I'm expecting to see a welcome message. In the other case, instead, I'm testing an error scenario, so I'm expecting to see an error message. So then, all the rest is pretty much the same. And so we, as developer, when we see something that's pretty much the same, we immediately think, okay, so probably I can write a function for that, so I don't have to repeat myself, right? So I might end up writing something like this, where basically here we have everything that I presented before, just dividing different functions, one for each step. Okay? In this, once that I have all those functions for me, the two tests, the success scenario and the error scenario, will look something like that. So they are much cleaner. They are literally just 5 steps: run the app, enter the username, enter the password, tap on the login button, and verify something. And we can say also that they are fairly understandable by non-technical people, right? So, okay, we might think that this is the way to go, but of course, if we start to write function for every action that we want to perform during an integration test, we might end up, or we definitely end up, having a massive test suite file, right? So already for this simple scenario where we're just testing two different scenarios, we have a few actions we have to perform. Just imagine like how many actions we have to write there to cover a whole user journey that we perform during the integration test. So we end up with high chances of having boilerplate code, and in general, this is not good for scalability and basically to have our app to be our app in a modular way. So let's see now how the robot pattern can help us, how we can overcome this issue or at least mitigate the issue. The robot pattern is a pattern introduced by Jack Walton to improve UI tests written in Kotlin for Android application. However, this is a pattern that can be used for every kind of UI testing, and it basically it doesn't really depend on any language or any platform we are going to apply it to. Okay. And as you can imagine, the core component of this pattern is a robot. So a robot, as you can see there, is just a class that encodes the high-level actions that we want to take on a view, or anything else that is needed to run the test. In other words, it's basically, you can consider like me as a robot if I'm asked to enter a username, to enter the password, tap on the login button, verify that I see a welcome message. That's kind of what a robot is. What is the final goal of the robot pattern? The final goal is basically to try to separate what is the what of the test from the how. So on the left there, you can see what is the what of the test. Basically, if a user enters email and password and they match, the user should see a welcome message. That's the what. That's what probably most of the product manager or stakeholders are interested about. The how is basically that word piece of code that you can't really see it there and you don't need to, but it's basically that code that we saw before. And no matter how we group it, if we write functions for different actions, if we create different components for it, that's the code that we have to write to run this test. Okay? So we can see the robot as kind of a man in the middle between the test and the view. So basically forwarding action from the test to the view and reporting back to the test. In the sense of what is what and what is how, we can see that our test suite is basically the what. That is something that is variable for the stakeholders, it's understandable by non-technical team members, and we do expect to be like very simple to read and to go through. Instead, the robot will contain the how. This basically will contain the implementation details of the test, and will most likely be understandable only by technical team members. So, coming back to the example that I did at the beginning, this what test, as you can see, everything is just in one place. We have the what and the how together. So, I will zoom in a bit in a different section of this file, but basically this how is our logging robot. So that we can divide basically in three main sections, okay? So the logging robot, you see, as I said, there are three different main sections. The first section are where we define the finders, and the finders are basically help us to identify in the view all the UI components that the robot will be interacting with. Okay. Then the second section of the robot are, of course, the actions. So all those actions that the robot can perform on the view. In our case, very simple, just enter username, enter password, and tap on the login button, right? And then at the end, we have the expectation. That are basically those functions that allow the robot to verify that some expectations are met. In this case, I want to check if I can see either an error message or a welcome message. Then, once that we have all the how in one component, which is the robot, how the what will look like. So, the what, in the case of a success scenario for the login, the what will look like something like this. So, we have we first run the app, then we create an instance of the robot, and then from now on, we just ask the robot to do something in the test. So we ask the robot to enter the username, to enter the password, tap on the login button to verify that the welcome message is visible. Okay? And as you can see here, everything is very readable, understandable by non-technical team members. Even if they don't understand in the first time, pretty sure they will understand after that we explain them once. And then, of course, and the second example is just for the error case. So as you can see again, it's pretty much the same. The only thing that changes are the credentials that we use in the test and the final step to verify what message we get. Now, what are some of the benefits of the robot pattern? So first of all, it allows us to work with composable steps. So the tests, as we know, they are made of different steps. And the robot pattern allows us to kind of do one-on-one matching between what are the steps of the test, and what are the actions of the robot. So once that we have the robot in place with all the different actions, we can basically mix and match of those actions in a way that we can cover all the scenarios that we need during the test. So there might be also cases like, for example, the action of tapping on a back button, which is an action that we might perform on different screens, that it might be very handy to have, of course, the logic defined just one place and just recall it whenever we need it to. And with the robot partner, we can do that. Then, the other benefit, which is very similar to the first one, is that it allows us to work with composable modules. So, as I mentioned, like an integration test is most likely going to involve different screens, different modules. It's going to involve like an entire user journey, like sign-up flow, login flow, and so on. And in order to follow the principle of single responsibilities, we should ensure that each robot is responsible for one area of the application, in particular one screen, one widget. Is up to you how you want to break down the robot. So having different robots will help us again to use them in the scenario where we need them to be used. So when we have kind of a toolkit on different robots with different actions, you can see how writing tests just become a thing of putting basically things together, like taking some robots and taking some action from them, and make sure that we are following the scenario that we need to test. To make cleaner this concept, let's assume that now in our app we have this is the launch screen that the user sees when he launches the app, and the user can basically decide to log in or sign up. The user decides to sign up, then he realizes that he actually has an account already, so taps on the back button. Then again on this screen, we tap on the login button, and once that he enters the credential and tries to log in, he will see the welcome message. Okay, so probably in real life we're not writing a test like this where we go back and forward between screens, but we might have to, right? So someone might ask us to cover this scenario. And what I wanted to show here is that using robot partner will be in a position to do so. So let's assume that I want to write a test for the scenario that I just presented. So the first thing that I have to do, of course, is to run the app. Nothing new here. Then I will define, in this case, like 4 robots, not just one. So I will have one for each screen that we saw before. So one for the launch screen, one for the login screen, and another one for the welcome screen. And then, since I know that at some point in the app or during my test I need to tap on the back button or do some common action, I will also define a base robot, which will be responsible for those common actions moving forward. So once that I have my robots in place, I can start running my test. So my expectation here is that the user will, what I want to test here is that the user will tap on the sign up button. So the next step would be that the launch robot will tap on the sign up button. Once that I'm on the sign up screen, the user decides to go back to the previous screen. So the base robot will be responsible for tapping on the back button. Then again, I'm back to the launch screen, so the launch robot will tap on the login screen, and now I'm on the login screen. On the login screen, now we basically do what we've done so far. The login robot will be responsible for performing the following action, which are enter the username, enter the password, and tap on the login button. Then, at the end, the welcome robot will be responsible to verify that the welcome message is visible, since we are going now to a different screen, right? So, and then we can do like whatever else we want in this test. As you can see, this is like a major difference compared to what I presented before, where the login robot was also responsible of verifying that the welcome message was visible. I did that just to make it easier to explain what a robot is without kind of mixing multiple robots, but now since we are talking about modularity, I think it makes sense to contextualize it in the right way. So you should make sure that a single robot is responsible for a single component of your app. Defining the component then is up to you. Now let's see how we can leverage the robot pattern also in widget tests. And why we want to do that? Because I'm sure you are familiar with this pyramid here, where it basically says that for most of our application we'll be writing a lot of unit tests, a quite good amount of widget tests, and just a small amount, which is not always a small amount, but is a small amount compared to the other categories of tests of integration tests, right? So why we write a small amount of integration tests? Because they are slower, they're hard to maintain, but at the same time, we should take into account that the integration tests are the ones that provide us the highest level of confidence, okay? So we found like a nice way of writing integration tests. So how we can apply this also when we write widget tests. So why we should just be constrained of using this pattern only for integration tests, right? So at first, let's see what Flutter says about the widget test. So Flutter, a widget test, in other UI frameworks refer to as component test a single widget. The goal of a widget test is to verify that the widget's UI looks and interacts as expected. Testing a widget involves multiple classes and requires a test environment that provides the appropriate widget lifecycle context. Long story short, for me, is that a widget test tests a single widget, and it requires a test environment, right? But then also, Flutter says that everything is a widget, right? And this wouldn't be like a Flutter talk if I don't say that. So technically, I'm not saying that we should, but technically we could write widget tests for everything, right? So it's just up to us to decide again how much we want to break it down and when to start, what are the different level of widget tests that we want to run. Let's take in consideration some of the key properties of widget tests now. So they are much faster than integration tests. They don't require a device or emulator to run, but they have limited access to resources like networking and storage. So widget tests definitely cannot be used to run end-to-end tests. If we want to run an end-to-end test, we need to use integration tests. But the fact that we have limited access to, for example, resources like networking doesn't mean that we can't mock those resources, right? So in our case, we could just write the test that we wrote before, just mocking the resources, just mocking the responses that we get from the server, right? And we still be able to test if our app behaves correctly. Then, if there is an issue with our authentication server, it's another thing. We need an integration test to make sure that that is covered. But if we leverage the widget test in the right way, we can cover many scenarios more than what we could think. So, and in Flutter, the good thing is that integration tests and widget tests are very similar. The way how we write them is very similar because both use the widget tester to interact with widgets and test environment. So this, which I don't know how much is readable, it is basically the integration test that I presented before. So let's assume that now I want to write a widget test for the same scenario, so for the success scenario, right? So the widget test will look something like that. Where, as you can see, it's using the same robot, and the only differences are the way how we run the app and the parameter that we pass when we enter the username and the password. Why? Because, of course, the way how we run the app, while in the integration test we can just run the app and do our test, in the widget test, as I mentioned, we first need to prepare the environment, the test environment for the test that we are about to run. In this case, I'm just mocking the login response to be like SSX 200, but there you are free to use whatever mocking library you are more familiar with. Then the other differences that I highlight there are in the parameters that we pass in terms for the username and password. Of course, I changed them, like in the widget test, they are any and any, because since we are mocking the response, it doesn't really matter what we are setting there, right? As far as they pass the local checks on the app, I can put whatever. So, as you can see, we are in a position where we can share the robots, right, between integration tests and widget tests. So that will help us to reduce the boilerplate code. It will create a standard approach for writing integration, widget, and also golden test. And also, if, again, you are in a company where the QA team is responsible for writing integration tests, you will enable them to write those integration tests by focusing only on the what, because we, as mobile engineer, we already wrote the robot for them, because we use them to cover many scenarios in the widget test already. There is only one more issue, which is in Flutter, integration test and test are stored like in different folders. Widget test and I would say unit test are stored in different folders from the integration test, and those folders don't communicate between each other, so we can't really access to a file in a different folder. A workaround to that, if we really want to reuse the robots between the two types of tests, would be to create a separate package where we put all our robots, and then this is just a local package that we can add in our pub spec, and then once that we have all our robots there, we can easily reuse them to write both integration and widget tests. And that was the last slide for me. Thank you. Is there any questions? Yes?
You say one of the benefits is that non-technical people, stakeholders, can look at the robot test and easily understand what the code is doing. Does that ever happen? The reason I ask is I have never had my stakeholders want to know there are tests, they want to know they're passing, they have no interest in what's inside them.
Well, it really depends. Like my past experience, we had like a project manager that was used to write all the acceptance criteria, and we're using those acceptance criteria to actually write the integration test. Those were kind of the guidelines for us to decide when to write an integration test and when instead like a widget test would be enough. And we sometimes we didn't really share the like as you said, like the code with the project manager or other stakeholders. But what I want to give here is that they should be that readable that even non-technical people should understand them.
Thank you.
No
worries. Do you know any good open source testing frameworks that work well with this pattern? Things like reporting.
To be fair, I haven't used any so far because I just had like a very good time using integration test that comes with Flutter. But yeah, I'm happy to discuss with you if there is any open source framework that you've used before.
Thanks.
There's one more question.
Do you use robots for golden image tests?
Yes, we also use that. Of course, I didn't have much time also to show that. But yeah, I'll be happy to show you something maybe later. But basically, what we used in the past were kind of the golden test kind of embedded in a widget test. So we had a wrapper function where we just define what are the reference images that should be used for the golden test, and then all the rest would be just a widget test. So it would be easy like that. I don't know if it's clear.
that's awesome. And just a follow-up question. Have you had to deal with custom fonts when you're dealing with the global image tests?
Sorry, can you say it again?
Have you had to deal with custom fonts inside the global
Oh yeah,
image
with
tests?
the golden test, those are a pain. So it was like I think it was some months ago, and I think that one of the solutions was to just replace those fonts with one of those fonts where they put like all the squares or circles or something like that, or there were like some fonts that were actually compatible with a golden test. But I think you will not have any issue if you run them locally, but when it comes to integrate golden tests in the CI, you might have some troubles. In particular, like if you're running them on a Mac machine or a Linux machine. So
some web or game trouble. Right, awesome, that was amazing.
thank you. That's it.